Now, let's see what f prime says about f now. Okay, so in these lectures, we will talk about like the derivative and the shape of the graph. Okay, so before we start, maybe let us review the equation of a straight line. Okay, so we know that the equation of a straight line is y equal to mx plus b, where m is the slope of the line and b will be the y-intercept. Okay. Okay. So again, if we have the, again, if the line is increasing like this, then of course we say that the slope is positive. If the line is decreasing, then the slope is negative. If we have a horizontal line, then in this case, the slope will be 0. Okay. The last is actually it's not a function. If we have a vertical line, okay, in this case, the slope is undefined. Okay. Okay, so this is what we know about a straight line then. Okay, so now then let us look at the following graphs. Okay. Now you will see that the first graph we have is an increasing functions. Okay, and then again, how do we know that it's increasing? If the function basically is x1, x2. If x1 is less than x2, and then the output f of x1 is always less than f of x2, okay, then in this case, the function is increasing, right? So if the function is increasing, then now let's check it out, the slope of the tangent line, okay? You will see that the slope of the tangent line is always positive, okay? So again, if f is increasing, okay, then f prime is positive, okay? On the other hand, if the function is decreasing, so you will see that the f prime is negative. Okay. If the function is horizontal line, then in this case, f prime is 0. And if the line is a vertical line, then in this case, f prime is actually undefined. Okay. So remember when we say undefined, meaning it's not a number, you could consider that is either is infinity or negative infinity. Right? Okay. Now, based on the result that we have from here, then that means if the function is increasing, f prime is positive. If the function is decreasing, f prime is negative. Based on this observation, right? Then we say we have a increasing decreasing test, or known as ID test. Then if f prime of x is greater than 0 on an interval, then f is increasing on that interval. If f prime is less than 0 on an interval, then f is decreasing on that interval then. Okay, so now then let's see how do we actually graph the f prime then. Okay, so again, consider that this is the f function here. Okay. Then remember f prime meaning the slope of the tangent line at the point, right? Okay. Or is the slope of the tangent line of the function f then. Okay, okay. Then let's go back to, again, a little review about how do we find the slope, okay? So if we have a straight line, okay? So how do we find slope? The easy way to find the slope is the change in the y directions over change in the x directions, okay? That means it is y's over 1, right? This is kind of the idea, okay? So in this case, for example, from this point to this point, we change in the y direction is that many units over the change in the x directions, okay, that many units, okay. So, or if you have, again, decreasing function. So if the function is decreasing, then again, same thing. So the change in the y directions, now it will be the negative then, because we going down. If we go to the right, okay, then the change in the x direction is positive, okay, just like this. Okay. And now, let us look at the following example, okay. So you will see that for x is in between, again, x is in between -8 to -4, okay, here. What happened to the slope? You will see that the slope basically changed from this point to this point. So it's go up by 1, 2, 3, 4, 5, and 6. So change in the y direction is 6 units. And then now, in the x directions, 1, 2, 3, 4. So in this case, the slope will be 3/2. Or if you notice, we could actually just count it right here. 1, 2, oh, I'm sorry. It's 1, 2, 3. Go up by 3 units. And then 1 by 2, right? Now, look at the interval between -4 and -2. So in this case, we have a constant number. It means that the slope is 0 then. Now try to figure out the other two, okay? So between -2 and 2, okay, the slope go down by 3 units, 1 by 5. So if we y has the decimal, so it will be about -0.6. And now the last interval is between between 3 and 6. Okay. So the slope is equal to up by 1, 2, 3, 4. 1 by 2, 3. Okay. And now let's see how we finish the f prime graph. Okay. Yeah. First, again, I would like to, this is y, this is x. I put the scale on the x-axis, which is 2 here. Okay. Now, then the scale on the y, look at this. The biggest number is 1.5. And the smallest number is about negative 0.6. Okay. So maybe we could make the scale on the y like this then. So this is 1. This is 2. Negative 1. Okay. Okay. So I think it's okay now. Okay. And now the interval between -8 and -4. Okay. The slope is 1.5. So between -8 to -4, the slope is 1.5. So this is 1, 1.2, 1.4, 1.5 is here. Here. Okay. And how about between -4 and -2 is equal to 0. Okay. And now between -2 and 3 is negative 0.6. And now between 3 and 6 is, this one is about 1.3, right? So it's 1, 1.2, 1.3. Then now let us consider what happened to -4, x equal to -2, x equal to 3, right? Or maybe the n, 6, and -8. Right? Then you will see that again, for example, that -4. At this moment right here, the slope of the tangent, okay, it is changing rapidly, or maybe just change it from 1.5 to 0. Okay. So meaning what? At x equal to -4, is it 1.5 or is it 0? Okay. Well, actually, to me, I have a hard time to determine or decide it. So then now, the easy way to do is, why don't we put it open? Because it is undefined. We will not be able to define at the corner then. Okay. Same thing with this, right? Is it 0 or is this negative 0.6, right? Okay, so then put it open. So then in this case, then what happened to the endpoint? Again, we have nothing from the left or nothing from the right. So then in this case, say that is also undefined. Okay, so then in this case, what can I talk about this? Okay, now for example, if I want to find f prime of -6, here is -6 right here, then you will see traces that change. That means you will see that the answer that you have is 1.5. Okay. Then now, how about f prime of -4? It will be undefined, or we could say that it does not exist then. Okay. Same thing with f prime of -2, f prime of 3, and how about the end point, f prime of -8? Again, does not exist. Okay. So then now we know that if we have a corner point, then the derivative does not exist. Okay. And now the following theorems tell me that if f is differentiable at a, then f is continuous at a. Okay. The converse of the theorem 1 is found is 4. That's it. There are functions that are continuous but not differentiable. Okay. Then you will see that one of the example is absolute value of x. Okay. So the function is continuous, but not differentiable at x equal to 0 then. Okay. So if I want to sketch the f prime, then can write right here. This is 1. And -1 right here. Because the slope of the functions, okay, to the right hand side is 1. The slope of these functions is -1, right? So now, if the graph f contains sharp corner, gap, hole, okay, a vertical tangent line, okay, at x equal to a, then f is not differentiable at a, such as f prime is undefined. Right? But now let's talk about increasing and decreasing function now. Okay. Now you will see that most of the polynomial function is actually behave like this. Okay. The function is part of the function is increasing, then decreasing, and increasing again, right? So in this case, we could say that f is increasing on the interval between x equal to a and x equal to b. And also on the interval x equal to c and x equal to d. Okay. And f is decreasing on the interval x equal to b to x equal to c then. Okay. Okay. So right now you will see that the reason that I'm not using a square bracket, okay, in this case, is actually I consider that at this moment, okay, when you're at point B, are you increasing or are you decreasing, right? So therefore, in this case, we don't know. I don't know, right? So that's why I put open, okay, right here, okay? However, I need to warn you that some of the author, they believe that at this moment right here, okay, if you are, again, if you are increasing from the left, then actually they feel that, you are still increasing at x equal to b. So therefore, some of the author, instead of writing open, then they're using a closed interval. Okay, they close it. Okay. So again, it just depend on how the author believe. Okay. So when you work on like the WOMAP or homework problems, sometimes you have to, again, sometimes you have to read the problem to see if they want you to close, that means include the B or not include the B then. And now, let us talk about the first derivative test now, okay? So, it said that, suppose that C is a critical number of a continuous function f, okay? So now, then, let's talk about what a critical number is. Okay. You said that right here, a critical numbers of a function f is a number c in the domain of f such that f prime of c equal to 0 or f prime of c does not exist. So in this case, then let us look at our example here. Then to this problem, we have two critical numbers. They are x equal to b and x equal to c because its derivative equal to 0. Okay. Then of course, to this problem, then my critical number is x equal to 0 then, because in this case, f prime of 0 is undefined. Okay, does not exist. Okay, so then now, let's check it out, the following example now, okay? Now to this one, the first graph, the function is increasing and then to decreasing. So to the left side of this number, okay, then f prime is positive, and then to this side right here, the f prime is negative. Okay. So therefore, you will see that if f prime changing from positive to negative at C, then f has a local maximum at C. So from increasing to decreasing, so we have a local maximum at x equal to C. Okay. On the other hand, if f prime changing from negative to positive, meaning again the function is from decreasing, so f prime is negative, to increasing, f prime is positive. Okay. So from decreasing to increasing, of course, in this case, okay, at C, which is a local minimum then. Okay. And now, if f prime does not change sign at C, for example, if f prime is positive on both sides, okay? So in this case, this is positive, increasing, and f prime is also positive, increasing. So the end, in this case, you will see that what happened? This point right here is not maximum, not minimum. On the other hand, how about negative on both sides? Then, which is f prime is negative, f prime is negative, meaning the function is decreasing, then decreasing. So again, to this one is not maximum, not minimum then. Okay. Then now, based on these, f prime is positive or negative, we could work with what we call the first derivative side charge then. Okay. So in this case, again, remember f prime of C is either equal to 0 or undefined, does not exceed. Okay, this is a critical number. If to f prime we change it from positive to negative, meaning to the f functions, we changing from increasing to decreasing. So then in this case, at C, this is a local maximum. Okay. On the other hand, if to the f prime, we change from negative to positive, okay, meaning to the function f is from decreasing to increasing. So then in this case, C is local minimum then. Okay. Then now, what if to f prime is from positive to positive? That means the function is increasing, then increasing. So then now, this C right here is not maximum, not minimum. Okay. Same thing with negative, negative, meaning is the function is from decreasing and then also decreasing, right? So again, we will have no max or no min. So this is how we use the first derivative test to see if we have a local maximum at C or if we have a local minimum at C. Okay. Then now, what I would like to do next is I would like to find a way to try to graph the function from f to f prime. Okay. Okay. Then now let us look at the following example. Okay. So the top functions here is a position functions. Is related to the height versus time. And this function right here is velocity function then. Okay. And now let's see. Now, how do we actually when I try to graph the function from f to f prime, here is kind of like the step or procedure that I'm looking for, okay? Step one, I would like to find all the critical numbers. Okay. So in this case, remember critical number meaning f prime of c equal to 0 or f prime of c does not exceed, right? Okay. So meaning we are looking for maximum or minimum. Okay. Okay. And with a smooth curve, right? Maximum or minimum. Okay. Or if it does not exceed, meaning the function have a sharp corner. Okay. Or if the function is not continuous, or sometimes we have a vertical tangent line, something like this. Okay. Then now, step two, we would like to determine where the functions is increasing or decreasing. Then again, to the function f, okay, if we have an increasing and then the function is decreasing, then to f prime, it will be increasing will be positive, decreasing will be negative, right? And of course, this point right here is my critical numbers. Then this is exactly what we need to do. So we would like to convert it. The function is increasing and decreasing of the functions, and then change it to using f prime. So increasing of f is positive of f prime. Decreasing of f is a negative of f prime. Okay. Then this one right here is a critical number. Okay. So, and one thing that you know, if it is a positive of f prime, what does this mean to the f prime graph? The graph of f prime is about the x-axis. Okay. Then if it's negative of f prime, mean graph of f prime is below the x-axis. Okay. Then let's see if this is how we could break it out the problem to this one then. Okay. Okay. Then now you will see that to this one right here. Okay. So if I create the chart for f here, then now this is 5, and then this is 8 right here. Okay. Okay. The function is increasing, and then function is decreasing. And now from 8 to 10, again, the function is also decreasing. Okay. So to the f prime graph, meaning to the f prime graph, then increasing meaning is positive, decreasing meaning is negative, and then negative. Okay. Then now to this graph, you will see that positive is the graph is about the x-axis, negative below the x-axis, below the x-axis. Okay. And why do we have a hole here? Okay. It is because we have a sharp corner here. So that's why it's undefined, right? F prime of 8 is undefined. Okay. And then you will see that the slope, okay, to the left of 8, the slope is more negative than to the right of 8 then. Okay, so that, and this is a straight line here. So that's why the derivative, it will be the horizontal line here. Okay. Okay. So then in this case, we starting from the positive, and then to this f prime of 5 is 0 because again, we have a local maximum, and then the curve is a smooth curve. Okay. Then we go to negative. Okay. 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 Then now, the next example is actually give you, give you an idea how to actually estimate the slope of the tangent line, okay, at a given number x. Then. So now we would like to use the given graph y equal to f of x to estimate the value of f prime of 0, f prime of 1, f prime of 2, f prime of 4, f prime of 5, 6, and 7. Okay. Then now, what we need, we need a ruler to actually to help us to work on the problem. Okay. Then now, let's look at f prime of 0 now. Okay. So what I need to do is at x equal to 0, I would like to again move my ruler. Okay. Just touch the point. And then we would like to draw a straight line. Okay. And then now, f prime of 0, okay, then we are going to count from here to here now, okay? So in this case, the slope of this purple line here, it will be, we go up by 1, 2, 3, 4, 5, 6, 7, and then we went by about 1 unit, okay? So then in this case, the slope is about 7. And then now, let's see, how about f prime of 1, okay? So you will see that what happened, okay? Again, when x is getting closer and closer to 1 from the left-hand side, then you will see that the slope is from positive, okay? When it is getting closer and closer to 0, okay? then it is, again, you will see that is 0. And then now, when the function is decreasing, then the slope is become negative and more negative and more negative. So therefore, in this case, you will see that f prime of 1, which is the local maximum, right? It is equal to 0 then, okay? Okay. Then let's look at how about f prime of 2, okay? This one. Then f prime of 2 is this point here. Okay? Then again, what we could use is, we could use again, a ruler, okay? A straight line to get approach to this point right here, okay? Okay, so then we draw a line. And now to f prime of 2, we get it from this point to this point. So it seems that we go down by 3 units. Go down by 3 units, and then 1 by 2. Okay? So it's about -3/2. Okay? Okay, so now it is your turn. Now go ahead and try to see if you could figure out that f prime of 4, 5, 6, and 7. Okay? 4 is here. Then first of all, I know that the slope must be negative because the function is decreasing, right? Then you will see that f prime of 4, so it is about, we go down by 2 units and then 1 by 2. So it is about -1. And now f prime of 5. Okay, so let's go down by 1 and 1 by 3. And now f prime of 6. Then it is about 0. And now, how about f prime of 7? I know that it must be positive, okay? Because the function is increasing again, right? Okay. Then let's see. So maybe we could count it from this point to this point. So we go up by 1, 1, 2, 3, 4, 5. Okay. Then now remember, your answer and my answer may not be the same because it is depend on how you draw the line, a straight line that approach to the point, right? Okay. Okay, so now then let's see how do we actually again graph the functions. Okay. Then 1, 2, 3, 4, 5. 6, 7, and 8. Okay. Then the highest number is about 7. Two, 4, 6. Okay. Then now f prime of 0 is about 7. By the way, this is f prime, okay? And then now let's go to 0. And here is about -2. Okay. Then it is about negative 1.5, then -1, and then -1/3, and then 0, and then about 1/5. Okay. So then now we could chase it back to the graph. Okay. So maybe we could consider something like this. So now this is my f prime. Okay. Again, let's see if we could apply the technique that we just learned. Okay. From here, again, find the critical numbers, determine where the function increasing, where the function decreasing, and then convert it to f prime. Okay, the side charge for f prime. Okay, so now, first we would like to find the critical numbers. Okay. And now you will find out that x equal to 1, whereas my local maximum 6, it is my local minimum, right? Okay. So 1, this is 6 right here. Okay, again, this for my f functions. So it's from 0 to 1, the function is increasing. From 1 to 6, decreasing. And then from 6 on is increasing. Yeah. Then to my f prime, I need 1 and 6. So if the function is increasing, which is positive, decreasing to f prime will be negative to f prime, and then positive again. Okay. Then now, when I graph the f prime functions, the positive mean above the x-axis, below the x-axis. Okay. And of course, to this one is about the x-axis again. Okay. Then let's see if this graph behaves this way. So between 0 and 1, it is about the x-axis for f prime. Between 1 and 6 is below the x-axis. And then from 6 on is about the x-axis. Okay, yeah, that's work, right? Now, let us work on number 3 now, okay? So right now, I would like to work on the 3 graphs here. Let's see how we sketch the graph of f prime, okay? Okay. Then now, to our first example. What is the first thing that I would like to do? I would like to find the critical number. In this case, it will be x equal to 2 and 4.2, where I have the local minimum and local maximum, okay? Then second, I would like to work with the f functions. I indicated 2 and 4.2 on this line here. Then you will see that to the left of x equal to 2, the function is decreasing. Between 2 and 4.2, the function is increasing and then decreasing again. Okay. Then to f prime, again, I indicate the code numbers. Okay. 2 and 4.2s. And if the function is decreasing, then f prime is negative, increasing, positive, decreasing is negative. Okay. Then now, when I try to graph the f prime functions, it tells me that this interval is below the x-axis. Between 2 and 4.2 is above the x-axis. And after 4.2 is below the x-axis. Okay. Okay, let us sketch the function f prime now. Okay, so I will have the scale on the x-axis. One, two, three, 4, and 5. Okay. Then now I have a critical number, meaning in this case, my f prime of 2 is equal to 0, and f prime of 4.2 is also equal to 0. Okay. Then now the graph is below the x-axis, and then you will see that, okay, this part right here is almost like a straight line. Okay, so then maybe I could draw it this way. And then now it is less negative, less negative, less negative, and then to 0. Like this. And then after 2, then the function is increasing. So you will see that the slope become positive now. Okay, which is more and more positive. Okay, and then now you see is less and less positive now. Okay, and then becomes 0 again. So I have more positive, and then somewhere we make it less negative, less positive, and less positive, and then to 0. Okay. And now is negative. Okay. Well, you see, it's become more and more negative. Okay. Okay. So maybe let's see something like this. Okay. So then this will be my f prime now. Okay, so now it is your turn. Now go ahead and try the next two example now. Okay. Critical number x equal to 0, okay, to f. So the function is from decreasing to increasing. So f prime, so it is from negative to positive, right? Right, this is x. Okay. Okay. And then now you will see that we have, again, the slope is negative of the tangent line. Okay. Then is more negative, more negative, more negative. And then somewhere here is turn is less negative, less negative, and then to 0. Okay. So in this case, it gave me the idea that is starting is less negative. Okay. And then more negative, and then somewhere is turned to less negative and to 0. Okay. Then now to this one right here, okay, we have a positive slope, okay, and then more positive, and then somewhere here is turn less positive, and then again really close to 0, right? For this one, okay. And goes to 0. But again, it is not going to be 0 because if it's 0, meaning we will have another like maximum or minimum occur, right? Okay. Okay. So the last example. So again, my critical number x equal to 0. Okay. And to f. So it is from increasing to decreasing. So meaning to f prime, it is from positive to negative. Meaning the function will be above the x-axis to below the x-axis now. Okay. 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 So then now let us look at how is this graph behave. Okay. So you will see that when we have really close to the edge, we kind of like we have a tangent line, right? Which is vertical tangent line here. So meaning the slope that I have, again, because this is positive, so meaning the slope that I have is really, really large and positive then. Okay. Okay. So therefore to this one, probably in this case right here, I will have a vertical asymptotes. Okay. Here. And then now, okay, the slope of the tangents is really large and positive, but the slope is decreasing, okay, and to 0. Okay. So therefore we will have really large and positive, meaning probably is positive infinity, okay? And then going down to 0, okay? And then now we have it negative now, okay? And then it is become more and more negative. Okay. More and more negative. Ooh. And it is getting bigger and bigger to the negative infinity, okay? Okay. So I need to adjust my y. Okay, so then this will be my f prime in this case then. Okay. Okay, so thank you then.